All right, so for question number 70 on the CP practice final exam, it corresponds to question number 68 on the honors final exam practice. We take the same reaction we started with in number 69 and we balance that equation. Okay, so we're going to put CuSO4, and I'm going to leave room for the physical state. Then we're going to put Fe. We're going to do the arrow to show what the products are going to be. We'll have Fe sub 2, SO4 in parentheses with subscript 3, plus Cu. All right. So I can see that these formulas appear to be balanced already. I would double check if it were me. I can see that sulfate has a 2 negative charge if I look it up on the common ions list. Sulfate has a 2 negative charge here. If you're in honors chemistry, you're supposed to have memorized that. Copper can have either a 1 plus or a 2 plus charge. And so if it's a 2 plus charge, that would work out right there. Iron is going to have no oxidation number at all because it's by itself. We can look up on the solubility rules. If you're in the honors class, you're supposed to have memorized the solubility rules, and you should know that most sulfates are soluble. And so, we're going to call this aqueous. There are some exceptions about sulfates being soluble. If you're in an honors class, you're supposed to know that. But if you're in a CP class, you can use the solubility rules. And sulfates are all soluble except calcium, strontium, barium, mercury, lead 2, and silver compounds, and this is copper. It's not one of those. Therefore, this is still aqueous. All right. Iron is a metal, and you should know that because of where it is in the periodic table. So iron is over here on this side of the periodic table. It's on the left side of this stair step. Stair step is here. It's over here. Everything over on this side is a metal. And metals that are by themselves, with the exception of mercury, are going to be solids. And we said that sulfates are soluble. There are some exceptions. And we said that we didn't say that iron was one of those exceptions here. So this is also soluble. And then copper is going to be a solid because it's now a metal by itself. Well, in order to balance the equation, you need to know the equation is moving forward. And so on the solubility, on the activity series of metals for CP classes, we can see that copper is lower than iron. So iron will displace copper. It'll go over here and kick copper out. So that means that we have a driving force. If you're in an honors class, you don't have access to that information, but you do have access to, if I can find a copy of it really quickly. And of course, I don't have it right here, but if you look it up on your redox list, you'll see the same thing, basically, that iron is more active than the copper. So this reaction does proceed forward. Now we're ready to balance the equation. To balance the equation, we have to have an atom inventory. So we write out Cu and S and O and Fe, and we make a kind of grid here. We count up all the elements on both sides of the equation. Copper, we have 1 of those. Sulfur, we have 1. Oxygen, we have 4. And iron, we have 1. Over on this side, we've got 1 copper. We have a 3 outside the parentheses next to this sulfate. So that means I have 3. Since I have 1 sulfur right here, the 3 outside means I multiply that 1 times that 3, so that's 3. The 4 next to the oxygen means I have 4 oxygens for each sulfate, and 3 times the sulfates will give us 12 oxygens. 3 times 4 is 12. And we can see we have 2 irons. So we need to now put coefficients in the equation that will give us the same number of atoms on both sides. So I'll leave oxygen for last. The place I'm going to start with is sulfur. Since I have 3 on the right, only 1 on the left, I'm going to use a coefficient 3 in front of the whole species. And I'm going to change the number of coppers and sulfurs and oxygens to match what we actually have now. We have 3 coppers. We had 1 sulfur, but now we have 3 times that. That's 3. We had 4 oxygens. Times that 3 is 12. So the sulfurs are now balanced, and so is the oxygen when you get the coppers and the irons balanced. So copper, we can see we have 3 on the left. To get 3 on the right, you put a big 3 in front of that copper. And I'm going to change the number of coppers to 3. And so what's left is iron. I can see I have 2 on the right. To get 2 on the left, I'm going to put a coefficient 2 in front of it. And that's going to give me 2 irons. And so now you can see, because the numbers all match up in this atom inventory, then this is the correct balance for the equation. If you've done everything else right, that's the way to balance the equation.